is Parsha, and I'm going to talk to you guys about mixing JavaScript and CSS. So before I start, I want to warn you. This talk is about ideas, not code. Even though I'm going to be showing you a lot of code, I'm not necessarily saying it's a good idea or that if it'll even work. My goal here is to share some ideas and get you guys thinking. So if you hear anything that you think is awesome and might solve your problems, or if you think I'm totally crazy, then you should come find me and tell me about it. So before we talk about JavaScript, let's talk about CSS. CSS enables us to take websites that look like this and turn it into this. CSS even makes Craigslist look better, going from this to this. I didn't even think Craigslist used CSS. Aside from enabling rich user interfaces, CSS also lets us create cool animations and other visual effects. Like whatever this thing is, that's actually not showing up on the projector. So let me just show you that there is something on my screen. And it's kind of neat. This is an animation that's utilizing the GPU to compose several layers together and then transform them on top of each other. Oh, there it is. So yeah, CSS is pretty awesome. But CSS has its fair share of issues and limitations too. There's no way to define constants. There's no way to extend a language with your own logic. There's basically no dependency management. We have the import rule, but there's limiting performance characteristics there. There's no way to reuse code or do any sort of metaprogramming. And there's no interoperability with the rest of our front-end code, JavaScript. Sometimes these limitations are good. They force us to write easy-to-understand code, but sometimes, especially in large-scale apps, these limitations often lead to copy and pasted code and stuff that's hard to maintain. But we've been able to work around these issues by creating new languages we call CSS preprocessors. We've been able to work around some of these issues, at least. But preprocessors are weird. They often have ambiguous syntax and non-standard semantics. And they give us features that look and smell like things we're used to, like functions, but then their behavior is different in unexpected ways. Let me show you a couple of examples of what I mean. Let's take a look at stylus. For those of you who are not familiar with stylus, stylus has very terse syntax. Basically gets rid of things like semicolons, curly braces, colons, basically almost everything. Let's take a look at this example. Here's the compiled output. We get what we would kind of expect. There's a form that gets a color applied to it, and then there's an awesome font applied to inputs and text areas inside that form. But what would happen if we accidentally swap two lines in our stylus source? So in case you didn't see that, let me do it again. The top two lines get swapped with each other. Well, this no longer really makes sense. The source doesn't make sense. What do you guys think will happen? Hopefully, we get some sort of compile time error. Nope. Stylus gets a bit confused and instead thinks our color declaration is actually a selector. This is still valid CSS, so there's no error. Hopefully, the developer catches this, but it's going to take some effort to debug. Let's take a look at less. Less gives us a way to import dependencies. Actually, less gives us 8 ways to import dependencies. And they all have their different semantics. Actually, sometimes they have the same semantics as others depending on the condition of what we're importing. Basically, you end up having to look at the docs every time you want to import something. Let's look at variables. Sass gives us variables. Here we have a variable defined called heading color, and then we use that to set the color of H2 elements. But we're defining the variable twice, once before we use it and once after we use it. In the output, Sass uses the first assignment of the variable, and we get red. But let's see what less decides to do. We have the same thing, but here, less does the opposite thing. Less uses the value that we last assigned to the variable, and we get the value white. Weird. Maybe not either of them are wrong, but you just got to get used to it and make sure you switch into the right context when you go between languages. Less also lets us do arithmetic. Here we see 10 pixels minus 2 pixels is 8 pixels. Great. But you better be careful with spaces, because adding or removing spaces might change the result. That's right, white space sensitive math. And you better be careful with parentheses too, because parentheses will change the result in an even worse way. So what else can less do? Less has this awesome feature. It can automatically convert units for us. So here we have the same values, but using different units. 10 centimeters minus 1 centimeter, and 10 centimeters minus 10 millimeters. Both come out to 1 centimeter. Cool. Let's see this in action with division. Here we have the same units on both sides of the operator. 10 centimeters divided by 1 centimeter, 10 centimeters as you would expect. But what happens if we mix units like we did with subtraction? Doesn't work. Less silently ignores units on the second operand when you're doing division. So with less, we can do arithmetic, but you got to be really careful. So my point is, language design is hard. Syntax, scoping, types, compilers, error handling, all these are really complicated things. It's understandable that these preprocessors have gotten some of them wrong. So CSS is cool, but it's got issues. We've got preprocessors to solve some of these issues, but preprocessors have their own issues. Is there a better way? Can we use JavaScript to do CSS better? Well, let's take a look at what using JavaScript to write CSS might look like. Let's express a simple rule in JavaScript. Here it is in CSS. We've got a red button. Let's convert it to JavaScript. It's actually not too different. We basically add some quotation marks, change out semicolon to a comma, and we've got valid JavaScript syntax. All right, that's a pretty basic example. What if we had pseudo-selectors? We wanted to have a hover state for our button. Well, it's not too much different from CSS or one of our preprocessors. And we can do even more complicated selectors, child selectors and descendant selectors. Still nothing too surprising, I hope. And here's the media query. And in CSS, sometimes we want to do something called property fallbacks, where we define a property more than once so that browsers that don't support a certain value can fall back to previous ones. In JavaScript, we can't quite define the same property more than once in an object, but we can use arrays to accomplish this. CSS also has a bunch of other @ rules. @charset, @keyframes for CSS animations, @fontface. Rest assured that we can express all of these things using JavaScript. So we've got rules with selectors, with pseudo selectors, child selectors, any kind of selector really. We've got property fallbacks, media queries, @rules. That's pretty much all of CSS. So I think it's safe to say we can express CSS using JavaScript. And it's pretty simple too. All we're using are literal expressions. This is essentially JSON. So we can express CSS in JavaScript, but how do we actually use this JavaScript in a browser to style elements? So far, we've got these plain old JavaScript objects, but we need to turn this in a way into something that the browser understands. Well, all we really need is a function that can transform one of these objects into a CSS source string. Now we can take the CSS source string and let the browser use it. So yes, we can express CSS using JavaScript, and we can use that to actually style elements in the browser. Awesome, JavaScript for everything. But why would we want to do this? Are there any actual advantages? To start with, remember the issues and limitations of CSS that I raised in the beginning of this talk? The reasons we've invented all these new languages, the CSS preprocessors? Well, JavaScript solves, or at least addresses, all of these issues for us automatically. Let me show you what I mean. CSS has no way to define variables. Less and Sass both give us this ability, but they have their own weird semantics. JavaScript has variables built in, and with semantics, we know and understand. We can use variables to define our constants in one place. JavaScript also has arithmetic built in. 10 minus 2 pixels is 8 pixels. And best of all, unlike some CSS preprocessors, it doesn't matter how many spaces or parentheses you use. You still get 8 pixels. In CSS, we have no way to extend the language with our own logic. Say we wanted to mix two colors together. In CSS, we would have to pre-compute this value and hard-code it into our source code. Less and other preprocessors give us a set of built-in functions that we can use to do some basic things. But we still can't define our own logic. With JavaScript, we can define arbitrary functions. Here, we create a function that mixes the two colors for us. We can even share this function with the rest of our front-end code. Of course, we don't actually have to write our own functions. We can take advantage of the JavaScript ecosystem and use modules to do the work for us. Here, we're using the color module from NPM to do the mixing of the two colors. And we're not limited to just functions that operate on colors or single values. In JavaScript, functions are the most basic unit of code reuse. We can use functions to generate entire sets of style declarations. Here, we have a function that takes in a base color and generates styles for a button based on that color. We're getting the same sort of code reuse we get as what some preprocessors call mix-ins, but with semantics that we understand. With CSS, we have no way of sharing values between CSS and the rest of our front-end code. For example, here we have some CSS that defines a color. Then, say we have some JavaScript code that draws to a canvas. And we want this canvas drawing to have the same color as we define in CSS. Sure, you guys have probably run into something like this before. You end up having to leave comments to tell other developers that when they change one of these variables, one of these values, they have to make sure they go into the other place and change that value to match too. This is brittle. But if our styles are in JavaScript, and our canvas code is in JavaScript, it becomes trivial to share values between the two. Of course, we don't need everything to be a single file. We can use modules to organize our styles and import dependencies. And it's just JavaScript, so we can import whatever we want: constants, functions, or entire sets of style declarations. Speaking of modules, we can take advantage of NPM. Not only do we have access to the 150,000 modules, we can use NPM to publish and reuse style modules. Imagine having an ecosystem of reusable styles for things like buttons and tables and other common interface elements. Or utility modules that help you build styles. For example, a module that takes in a background color and automatically generates a foreground color for you that has good contrast. Spoiler, that module already exists on NPM. So I've shown that there are advantages of using JavaScript to write CSS. By using a Turing-complete programming language to build our styles, we're not limited to what our CSS preprocessor has implemented. We can instead use the full power of JavaScript to implement whatever logic we need. We don't need to reinvent variables, functions, scoping, or anything else. JavaScript has all of these things just waiting to be used. Of course, with great power comes great responsibility. Maybe it's not a good idea to do a network request to build your styles, but that should be up to you to decide. So we've successfully used JavaScript to write CSS. How else can we mix JavaScript and CSS? Let me pause for a second and tell you that you should consider the following experimental thinking. The details are vague. I don't know if it's a good idea, and I definitely don't know if it'll even work. So think about it and give me your feedback. But let's see how else we can mix JS and CSS. We can use JavaScript to apply styles in the browser. What I mean by this is taking over the browser's role of parsing CSS and applying styles to elements. I know this sounds crazy, but bear with me for a second and let's see what we can do if we do this. First, writing CSS in JavaScript, like I've been talking about, is not a prerequisite to this. You could just use regular old CSS, actually. What is a prerequisite is having some sort of CSS abstract syntax tree, or CSS AST, available to us in the browser. What I mean by this is we need to be able to take a CSS source string and be able to understand and inspect it and see exactly what's being defined in that source. Of course, there's an NPM module for that. Here, we're parsing a simple CSS rule. We have access to the selector, the declarations, what property is being defined, and what the value is. And of course, we can do the inverse. We can take a CSS abstract syntax tree and generate a CSS source string. Cool. But what does this enable us to do? Well, CSS has a new feature called CSS feature queries. It's kind of like media queries, but instead of testing the device's width or orientation or something like that, we're able to test whether a device supports a certain CSS feature. This example lets us use Flexbox if the browser supports Flexbox. Otherwise, we use float. Unfortunately, not many browsers support feature queries yet. But if we're executing JavaScript in the browser, then we have access to information about that browser environment. Like, for example, whether or not the browser supports a certain CSS feature or not. And if we can access our CSS abstract syntax tree, like I showed earlier, then we can use that information about the browser and transform our CSS into new CSS. Then we can take that new CSS and inject it back into the browser by injecting a new style tag into the document. This means we can take CSS and create new CSS based on what browser we're in. We can use this technique to polyfill CSS feature queries. We would walk the CSS abstract syntax tree, and when we come across an @supports rule, we would do the feature detection in JavaScript, and then based on the result of that feature detection, we could generate a new CSS AST, either including the rule or excluding the rule that's nested under the @supports rule. Now we have feature queries in every browser. So what else can we do? One of the browser's jobs with CSS is to take selectors and figure out which elements match. Then the matched elements get styles applied to them. In this example, the browser knows to apply the color red to our span because the span is a child of a div element. That's what our CSS rules selector specifies. Another way we can take over the browser is by doing this matching and applying of styles ourselves. This means for each CSS rule we have defined, we would find all of the elements that match using something like query selector all. And then for each matched element, we would apply the rule styles to the element. Why would we do this? The browser already does this for us. Well, again, it's about having new information. This time, we would have information about the hierarchy of elements in the document when we're applying styles to an element. Meaning that for each element we're applying styles to, we could see what its parent is, what its children are, how many siblings it has. We would know exactly where in the document's hierarchy that element is. This information lets us polyfill even more CSS features. Take first child and last child, for example. If we know about the siblings of an element, we know the position of an element within its parents, then we know if it's the first child or not, and if it's the last child or not. This means we would be able to implement first child and last child ourselves. So when we're iterating through elements, we can use this information about the element's position to determine if the element should get our first child or last child styles. Though that's not really too useful, since basically every browser supports first child and last child natively. But with the same kind of information and the same technique looking at the document's hierarchy, maybe we can polyfill something more useful. Flexbox is a new CSS layout feature that makes it easy to express all the crazy things we use floats and tables and various other layout hacks. If we know the flexbox styles we want to apply to an element, and we know that element's parents and its children and all the styles of those elements, then we can calculate the position and dimensions of every element. This example has a flex container with 2 children, each with an equal grow factor of 1. This means we would have a container that has 2 side-by-side columns inside of it, each with equal width. I was able to determine that by just looking at the CSS and our document's hierarchy. Of course, computers can do this for us too. And you guessed it, there's an NPM module for that. So if we can describe our document, creating a representation of our document hierarchy and the styles we want each element to have, then we can use the CSS layout module to calculate the layout of our elements. So here we're describing the document I showed in the previous example, a container with 2 flex children. So if we pass the right information to CSS layout, it can calculate the exact dimensions and positions of each element for us. Here we can see we end up with our parent and 2 children side by side, each with equal width. We get the width, height, top and left of each element. That's awesome. I think we can use that to implement a runtime Flexbox polyfill. I think we're in a really exciting place right now. The JavaScript module ecosystem is implementing some great things. I think it's going to be really interesting to see what we can do with them. So I hope I've shown you some interesting ways you can mix JavaScript and CSS and essentially re-implement the browser in the browser. Come find me and talk to me about any of this. I'd love to discuss it. You can also tweet me at Parsha. Thanks for your time.